Hello viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about data logger. So let's dive deep into it. So why do we need something like a data logger? Well, here's the many things become very clear when you have temporal resolution. Like we human as a species, we are very in tune with high speed things. Basically, you poke the battery went boom. We are like, we know this, we got this, we understand this, and we built very high speed machines known as oscilloscope that allows us to see inside a second. Meaning, let's say for example, you have a PC fan that is PWM fan, and this puppy would require a control signal pulse width modulated signal in 25 kilohertz. That is way too small of a signal to see visually. But if you have oscilloscope, you can see the duty cycle without any issue. So same way, oscilloscope is allowing us to go deep into the temporal resolution, basically what's happening inside a second. Sometimes we need to zoom out a bit. Basically, we need to see the slow, how things are changing over time. For example, if I tell you how a battery goes boom, that's a quick event. Like you poke it, it goes boom. Okay. But how plants are reacting to changes in soil pH? Can you record it in one day? No, you have to record it through their whole germination cycle, basically whole lifespan. Basically, from plantation to extraction, you have to go through all that. Only then you can see what actually happened. Many things require that. Like if I give you a sea and be like, hey, this sea is drying out, human brain cannot comprehend that sort of change. Especially if it's like, oh, this river, like we built a dam caused the rivers to dry out. It's very hard to digest. But if I show you, let's say, a picture, year over year, like let's say 2005, 2006, 2007, 2008, 2009, now your brain can comprehend it. So same way, temporal resolution is the key, meaning sometimes you want to see as quickly as possible. So you will go inside a second. Sometimes you need to stretch it out. You need to overlap large periods of time. So there is a lot of basically disciplines where all disciplines requires this sort of thing. Meaning if you want to understand a national energy consumption, you cannot do any unit less than basically a year. And practically speaking, it has to be years. So you do not have any odd things. Basically, if you get the data from lockdown year, the result would be messed up. So that's why, like, if you want to understand how a nation is consuming energy, you have to get at least, let's say, 5 years of data overlapped on each other. Then you will have a good pattern understanding. So there is a fundamental need of logging data over longer periods of time rather than going inside a second. So from cell charging, let's say you are charging a lithium ion cell, how does it react? When does it switch from, let's say, constant voltage, basically constant current mode to constant voltage mode? You need to know. So all those sort of things require certain level of logging. Paint drying, now, like, who the heck cares about paint drying? Everybody. Who do you think like makes a paint? Like, which compounds to use, how should it be applied, all of that, like which environment it is. Like, for example, in paint environment made for a very humid environment would be completely different. Paint made for high UV index area would be completely different. Who do you think tests this? How do you test that? It can't test it like apply that it's good. It has to be tested over a very long duration. So that's why there is an absolute need of it in every domain. So what is this data logging? Data logging is a very simple thing. You do data logging, basically you collect the data and you store it. That's the fundamental job of a data logger. You collect the data and you store it. And user selector basically user selects the sensors or quantity, and both of them basically. So for example, if I'm working with batteries, I may select voltage and current sensors, because again, that's my domain. Sometimes, let's say you are working with solar panel, you may select same voltage and current, but you may be like, hey, what if I add two more sensors, temperature sensors and humidity sensor? I want to understand how it affects the energy output of my solar panel. That would be a really good requirement. On some scenarios, you will be like, hey, I'm studying botany, I want to understand how these plants are reacting. You may be required to, like, hey, let's study the pH. Like, does pH change in soil? Yeah, but again, the changes are not very well changed. It's very dinkichika. So you need to collect data over the years. You may need to collect it annually. You may be like, hey, in this season I'm seeing the plants are reacting differently, so they are consuming a bit more, changing the pH, or some invasive species happened. All that thing, you have to actually understand it, and it cannot be seen in one snapshot. You need to have movie of it, time lapse of it. So that's why, like, the botanists spend a lot of time collecting those sort of data. It may feel like odd. It's like, who needs to know that? It's like, it's absolutely necessary, and it applies to every field. So time stamping is also necessary, like how far away it is. Like, again, without time, that data won't make any sense. So like in this scenario, I can tell you, like 2010 this happened, 2012, 2014, 2015, 2016. So you have it anchoring of their data. So how there are two vectors how you can anchor the data. First, elapsed time. cheap method, but again does work. Let's say you from start it will count basically 10 second, 20 second, 30 second, 40 second. It will keep counting when you started. So it will like 1 hour, 2 hours, 3 hours, 5 hours, 500 hours. It will keep going like that. Then you have real time, basically a real world clock synced to it. Then it would be like, at 6 p.m. This happened, 7 p.m. this happened, 8 p.m. this happened. So you have timestamps, and that allows us to study it. Without that time, it can't be anchored. So in small case things, you generally will have elapsed time. Basically, you are monitoring something for 1 hour or 2 hour. Elapsed time would be a good thing. But if you are monitoring like let's say soil and all that or weather, you need real time. That would be far more appropriate. And let this be very clear, anything that can be measured can be logged for further and deeper study. And yes, it goes with everything. Basically, election results would be affected by weather. Like, wait a minute, that can happen? Oh, yes. Oh, yes. Trust me, that's why we have that data logging for that. So everything, like how do people vote for election, how much people show up for a game in stadium, all that data is logged, and there is essence to be extracted from that. Now, of course, it will not tell you absolute future, but it can give you a good idea. Rather than your margin of error being this much, if without data logging, you can reduce the margin of error this much. And it does work. That's why every company invests. Electronics do not even start without it. Like solar panel, how do you know a solar panel is manufactured by someone who knows what they're doing, and someone who's like, I'm just buying cells and blocking it up? You won't see this graph on a cheaply done system, or the graph would be copy pasted from someone else. But professional ones, they will always verify this, and that's how they can fight a reject warranty or accept warranty. Because again, if this graph is not matched, they want to know why the heck your panel did not do that. Did panel cracked during transit? Did something else happen? They would like to know, so they will collect it from you and they'll study it. But if you do not have data logging, how would you know? So data logging is very critical requirement. So what vectors do we have? Well, vectors is, first vector is onboard flash memory. It's generally desirable for remote locations, or like if you are like, hey, I'm going to put it and forget about it, you can have that. Like you can even buy things like this where you have data logger and they just allow you to plunk a USB thumb drive to it, and then it just stores data on that. Some have SD cards, some have onboard flash memory. That's up to you. That's one option. Desirable for shipping things. Shipping industry loves that. For example, imagine this way, like you have hard drive shipment from Taiwan, and you are shipping that puppy to, let's say, India. Would you just send it? Hell no. You will put sensors there, sensor bug that will be passively logging all the data in real time. And again, let's say a ship went through some bad stuff. Basically, it hit ground somewhere, or like there was some debris in the oceans. Yes, there are floating freaking debris on the ocean that could damage a ship, and it caused a lot of damage, and ship vibrated too much. All the hard drives that are inside, yeah, they exceeded their safe threshold. Company at that point in time, once they collected, basically the agent on India side, they will open up, they will read the data, and they're like, hey, hard drive has crossed the red line. So at that point, they can make a decision. They can mark it as a refurbished, reduce the warranty, because they know, like, if they send it, it's a crapshoot at that point in time, whether it's going to work or not work. So they may be like, hey, all of this refurbished, and or they may be like, hey, you know what, these are enterprise grade hardware, we will not degrade our basically reputation, write them off. Yeah, you need to know. Otherwise, would you really be happy if you're like, hey, I made awesome products, I sent the awesome products, something bad happened in between, and customer is angry, and I am angry because all I'm getting is refunds? That's the whole point. So tethered, basically onboard flash memory is awesome for that. Then you have tethered system. Again, let's say you are working in a lab setting, all your equipments are very high grade, those are not portable. Like 10 digit multimeters are not portable. For example, you can have a lot of things that will require a like very precise structure, that like a physically hard structure. Those time tethered system would be really useful. PC system and SCADA systems, like SCADA system is fundamentally a PC only. So like you are talking about a power plant, of course you're not going to carry a freaking multimeter there. You're going to have a centralized system, and all that centralized data would be stored. So SCADA systems most of the time are like a tethered system, and PC is again done in lab scale or like hobbyist kind of environment. So all options are there, tethered or untethered. You have channels, basically how many parallel instances you are doing, because you can buy multimeters right now that can do basically data logging. Even EV vlog meter also does that. You can store data on SD card, but it will only give you one channel. Now, for example, this one, I can do 4. Can I add more? Absolutely. I can replace this INA2192 with a different variant that has 3, and I can have like 12 of those 3. So now I can measure very large sample size. Now that would be desirable. If I have like large battery banks that I'm working with, where I need to monitor a lot of cell, that would be desirable. Channels is required for that. Temperature also, for example, you may have a scenario where you're dealing with water treatment system. You may need to monitor pressure and temperature. If temperature is changing too much, there may be something messed up. So you may require that. And again, big systems require a lot of channels. So you can start with like 8 channel and go to hundreds of channel. And temporal resolution is often bare minimum 100 times a second, but I generally do not think you will find most of them. I did try to achieve that 100 seconds, basically 100 readout per second. Yeah, I did not. This does not have enough oomph to actually crunch that. You need much higher power, basically microcontroller to do that. So 100 times a second. But again, if you start to exceed that, then there are people who are like, dude, it's a high speed of data recording. And then few times a day. So for example, if you're shipping vaccines that are temperature sensitive, so the moment vaccines are created, the moment you log them, you will put a data logger there, and data logger will record, let's say, every 10-second temperature of it. And then let's say you shipped it. Shipping, again, you took very serious care, like, hey, it's going to be a refrigerated truck, you sent it to a refrigerated box, everything is fine. But again, something bad happened in between. How would you know? Like, let's say it was a long train journey and something broke in the train, and the cooling system malfunctioned. How would you know? If you have the data logger, then the person in the hospital who's going to collect that puppy, he can just open it up, put the data logger in the computer and be like, oh, okay, reject this patch. And then they can share it, and then you can be like, get your refund, or figure out what went wrong. How can you fix it? So that's why it's very desirable. Temporal resolution is up to you. And you have one luxury nowadays is very easy to do. Back in the days was hyper expensive, but now it's cheap enough, where you can have Stratum 0 level sync. What does that mean? Stratum 0 is world clock as in GPS world clock. Why GPS? Again, all clocks are synced to one master clock. That master clock is GNSS, as in Global Satellite Navigation System. Global network of satellite constellations. They act as a backbone of everything: stock market, internet communication, everything. What is time at this point in time? That is at Stratum 0. So nowadays, because of the low cost of basically GPS modules and super cheap units, you can have built basically weather station, where you can have a very simple thing. Let's say for some requirement, you just desire to have a solar panel. You want to use all the power of that solar panel to collect as much data as you can. It will only work in the daytime, but you're okay with that. Like, let's say you have a camera unit. There is no point capturing a photo at night. It's like, bro, I can't see any damn thing. So you may be like, hey, I'm completely okay with this. But yes, without continuous power on, clocks drift. And you may be like, what if I put a coin cell? Again, you can do that, but that's an extra hassle. And again, it drifts like crazy. Without an anchoring of that data, you are just lost. Or you can just like, hey, put a small GPS unit there and forget about it. And GPS units nowadays are very energy efficient, especially if they are outdoors. Don't even count their energy uses. So now any weather station you have that is getting Stratum 0 sync, meaning now you can sync that data with everybody else around the world who is doing it properly without any issue. So you can even, this sort of thing is done when you are calibrating the satellite. Because again, once satellite is launched, they requires calibration. How would you calibrate? If satellite is telling you this area is going through this humidity, how would you know? There are sensors in that area that they will calibrate against. How would you do that if you do not have time? Stratum 0 time is easily available. That's one way of flexing on people. If you want to hey, I'm doing solar installation and you want to really flex on it, you can literally have a GPS time data going into there. And like, is there a benefit? Yeah, eclipse time, those are very critical because your solar output will be very bonkers. You need to know it precisely. And if your data logging can show you, people are like, wait a minute, that's precise. It's desirable in many scenarios. So those are vectors. That's up to you. You can go all in, you can go very minimal. That's up to you, up to your requirements. So what options do we have? Well, options wise, most pro grade lab equipment, basically if you are dealing with something very serious, you are like, multi-million dollar equipment development farm. Yeah, those things already have it. You do not have to worry about it. Most of them have some sort of output logging functions built in. And many times they also have a data backhaul where you can dump all the data to some other long-term data logging, some server where you are just storing all the data. So it's an already solved problem. However, the equipments that do that properly, we do not ask the price of those. Those are expensive AF. Then you come to SCADA system. Basically, SCADA system, they have it by default, by design. So for example, if you are talking about a national power grid, it makes no sense unless you are observing over the year. meaning again, summer season would be completely different than winter season. So, but if you are taking only snapshot of a month, weather directly messed up your perspective. So you have to take multiple years. Average is generally 5 years. Then you can get some perspective, some contrast to it, and then you can see changes like, hey, solar eruption is happening, so I'm getting this sort of duck curve, as they call it. So, and that's how they will understand is like, hey, when do we have the most amount of draw? So they will make sure that all the maintenance happens either after that extreme period or before that extreme, never in that period. So they do not have any generation asset out of service. All those things require data logging data. Like there is a lot of data. Like this will be all real time, but here's, I can guarantee you, they will have a place where they can select, hey, so over month, so over this, and all of that data is studied thoroughly to predict what is going to happen. How do you think they can make sure the grid remains stable? They are studying it, they are projecting it, they are projecting, oh, this, let's say cricket match is happening, that means you're going to have bonkers amount of energy draw in some sectors, but very minimal energy draw in some other sector. If you know this, if you have observed this over years, now you know, you can be prepared. Hey, this sector, okay, put it in a low priority, put all the generation unit ready to go on this. Okay, match started, power draw went up, you're like, okay, we got this. So that's why it requires, SCADA systems have very high resolution systems for that. And you have tailor-made solution for different fields. For electronics, it's a whole ecosystem. I'll run out of time if I try to describe all. Soil, like you can buy equipments like this. It's very necessary. Like many times this happens, especially nowadays, is that soils are getting too cooked. Meaning if back in the days, farmers had a very simple logic where it's like, hey, I'm going to water it in the evening and I'm going to water it at morning. And I will be sorted. Like, easy peasy. They did not have to worry. But nowadays, peak summer heat wave can go so high that soil could be cooked. Meaning you may have watered it, but the peak heating could be so vast, so brutal, so quick that if you do not have a sensor, you will not know that your soil crossed the temperature threshold for your plants. Some plants can only tolerate, let's say, 50 degrees Celsius. But let's say soil crossed 55 degrees Celsius, meaning plant would be injured. It will not work properly. So if you have that data, then you will like, hey, I have to shift the timing. I may decide to water it like literally at peak summer, so temperature never reaches. So you can figure it out what time soil is at 40 degrees Celsius. Okay, soil reaches, let's say, 40 degrees Celsius at, let's say, 1 a.m. Oh, pardon me, 1 p.m. And it was like, okay, let's start watering at 12:30. So it never reaches that uncomfortable temperature for plants. It may waste water, but at least will save your crops. Again, I'm just telling you random vectors. They are like, that's why people do botany. Like there is a whole vectors. You need to know that data. Soil monitoring and all that. Weather system, obviously. And then you have shipping industry have like this sort of ecosystem where you have small units and you can put it like, especially groceries, they are sensitive to humidity changes and temperature changes. So you buy this unit, start it has a depletable battery, it will last for 100 days. Yeah, many of them have like such a high energy efficiency. On coin cell they can last that kind of long duration. And then at the your shipper is like, hey, I shipped it from, let's say, Africa, some unique roast of some coffees. They're like, hey, we shipped it to you from here. Okay. And like coffees will be awesome if they are kept at this sort of temperature. You put this logger in that package, and then once it's reached the destination, you're going to open it up, plonk it to your computer. This puppy gives PDF output, which is weird. I thought it will give CSV, but okay, PDF output, you open it up and like see it. Did it ever cross the red line? That's how it works. Like this is basically you have options as long as you have very deep pockets. You do not have to worry. Like for vaccines, for goods and all that, you can go all in. Many of them also basically passively store GPS data, meaning where they were transiting to. So you can figure it out. Somebody will be like, hey, we are going through the Cap of Good Hope because, this Red Sea is happening. And they were like, yeah, insurance premium is going up. So okay, you are like, okay, we'll pay you more. Okay, awesome. But here's it. If you do not have the GPS data, they'll be like, hey, what if we actually went from here? And again, I'm exaggerating, but smaller theft of that sort of caliber happens way too often. That's why these tools were built. So you have a lot of options. Now, I'm very proud to pronounce that our tool is also created, meaning S2C is now a live tool, serial to CSV. So benefit is with the help of my Epic community. Let us be very clear. Everybody says their community is awesome. I can prove it. We have tools for it. So our community built this tool because I'm not a programmer. I'm not anyone. So they built it. So what do you need to use this tool? Well, it's a toolkit. You need PC, you need microcontroller, and you need few sensors. What sensor? Up to you. What are you trying to measure? Let's say you are working on water heater. You will need temperature sensor and pressure sensors and all that jazz. That's up to you. What sort of puppies you need? Microcontroller. Which microcontroller? Again, I started this with Arduino. You can go with ESP32. So that's completely up to you, whatever microcontroller. I do have example sketch for Arduino in GitHub. You can look into it and you can ask share that to ChatGPT and ask it to tailor made it to your application. It's quite easy. You can manually do it, or you can ask ChatGPT, or if you are a programmer you already know how to do it. And then we come to the PC part. So all of the USB, there is a back and forth serial output. So using that USB, it's a tethered system, so you do need to be connected to computer, and using that part, this application will store all the data. So basically your sensor can send data to the microcontroller. Basically, when I was charging battery, it was collecting data, it was sending the data to microcontroller using USB, was sending to this application, which you can download free, open source. You can download and check it, and this puppy will store all the data in CSV format, comma separated value. So you do not have to worry about any application. You can use it in Google Sheet, you can use it in Excel, you can use it in OpenOffice, you can use whatever the heck you want to do. And we are working on also a tool, CSV to graph, for that reason. So you get the CSV and then you can plot out the graph. Like these two are charging output of two 18650 cell charger units. So you can see one of them like a much larger capacity, but it has oscillation. Again, I did not knew about this, but again, that's why we data log it. So now I can zoom into that area and be like, okay, what exactly happened? Why it was oscillating so much? Again, almost every charger will oscillate, whereas like if voltage drops too much, it starts to charge back again. But again, you do not want it to happen way too often. So again, how would you know? You have to put it there and forget about it. And again, this data recording was done, I think 2-3 hours. Yeah, 1 hour 20 minutes. So that's how you do. Output is CSV file, and you can take that file and draw it. However, if you are feeling bold, you can dump that data into Grafana. This is in Grafana, and you can zoom in. That's the main benefit. Here you can't zoom in into the graph, but here you can zoom in interactively. See, now I can zoom into like, hey, the width, basically oscillation width is shrinking. So there may be a chance where if I have recorded for longer, I may have noticed that it it flatlined. Again, is it a cell thing, or is it a charge controller misbehaving? Again, I can swap things and test it. That's why we need this sort of tools. Again, professional tools already exist, but again, are you rich enough to afford them? If you are, why are you watching this? If you are not, again, I got your back. So PC, microcontroller and sensors, and you're good to go. What about the refresh rate? I was too optimistic when I was launching this project. I was expecting 1 Hertz, 10 Hertz and 100 Hertz. Yeah, 100 Hertz is not happening. This microcontroller will simply cannot read out data fast enough, put that into CSV format. Oops. Yeah, put that into CSV format and send it over USB. Yeah, that's not happening. And this application is built into Python, so it can barely read at 20 or 30 Hertz. It cannot read at 100. It's not C++. So with that, as a data logging, it's more than good enough. You're going to get at least 25 Hertz. I'm getting that with this system. I'm pretty sure if you do it with proper ESP32, you're going to get more than that. But you can get that, and then you can go YOLO on it as much as you want. And in this scenario, I've even built date and time, but it's using computer's date and time. So computer date and time and elapsed time is also there. So that's why you can get the graph of first minute from charging, 10 minutes from charging, 30 minutes from charging. Or if you put in Grafana requires date and time. So in date and time is there. Now you can zoom in. What happened? So I was very happy how awesome my team is and how amazing work they did. And yes, we are working to expand it. And you may be like, why didn't I put SD card on all that? I want to do that, but those are very hard problems to solve. And since I do not know anything, it's very difficult to do it. And I will do it once I get time and money. So that's there, and I'm very happy, and I would urge you to just look into the GitHub and figure things out. And if you can help to make the application better, or the sketch part is the weak link. I'm very happy with the application. The sketch part is like could be a bit better. If you can help it, please commit there and I will attach to it. So that's one option. So you can create your own graphs and go YOLO on it. So this was my presentation on data loggers. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.